So number 16 says to write the equation of the line that would complete the parallelogram that we see here. So parallelogram means that the opposite sides need to be parallel. So if we notice here, we have our opposite sides here are parallel. So let's look at what the slope of this is. From here, we're going to go down 1 over 1. So you want to repeat and go down 1 over 1, which would give you your side here. So to find the slope of this particular line right here, we would have it being down 1 over 1. We need it to be down 1 over 1, which means the slope is negative 1. So then we're going to find the equation here, and all we need to know is one of these two endpoints. So I'm going to use the point A, which is here at 4, 1, 2, 3, 4. So at 4, 4. So we need the line that passes through 4, 4 and has a slope of negative 1. So we're going to plug that into y equals mx plus b. So my y is going to be 4 equals my m, which I found to be negative 1, times my x is going to be 4 in this case, plus b. So 4 equals negative 4 plus b. Add 4 to both sides, and b is going to be 8. So for the first part of this question, y equals negative 1x, or negative x, plus the b, which was 8. So that's the first part. Then it says to find the perimeter and the area. So since this is a parallelogram, we need to figure out, we could use the formula base times height to find the area. And so if you do that, you're going to need to know how tall it is, essentially from like this point to this point here at a perpendicular. That's going to get a little messy, so what I'm going to do is I'm actually going to create that outer boundary here, which we did before in an earlier problem. So going this way here, just because it's hard to see this. And we're going to find the area of this whole rectangle. So the area of the rectangle is going to be 1, 2, 3 units. So 3 times, then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So 3 times 10 is 30. So we'll basically be subtracting off these parts from this, 30. So starting with the small triangle here, the area of the small triangle is going to be 1/2 times the base, which is 1 unit, times the height, which is 1 unit. So that's going to be 0.5. And so we're going to be subtracting that off not only once, but twice, because there it is up there, so minus 0.5. Then we're going to do the area of the larger triangle, which is 1/2 times the base. So let's see, that's 1, 2 units, times the height, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there about 9, I guess it would be. And so that would be 1/2 times 2 times 9, which would be 1/2 of 18, which is 9 units. So essentially we're going to be doing 30 minus 1/2 minus 1/2, which is minus 1, minus 2 of those 9s, which would be 18. So essentially we are doing 30 minus 19, which leaves me with an area of 11 units squared. So that takes care of the area. And now finally we need to do perimeter. For the perimeter, we need to know how long each of these are. So what I'm going to do is I'm going to use the Pythagorean theorem, because you haven't seen me use this yet. So at this point here, to use the hypotenuse to figure out how long this hypotenuse is. And so if you'll look here, this is 2 units, and then this one here is 9 units. To figure out how long the hypotenuse is, we're going to be doing 2 squared plus 9 squared equals my hypotenuse squared. So that's 4 plus 81 equals c squared. So then c, when I take the square root of both sides, is going to be 4 plus 81 is square root of 85. So this is square root of 85. Since it's a parallelogram and opposite sides are congruent, that is square root of 85 as well. And then looking at this one, if we do the right triangle here, that's 1 unit and that's 1 unit. So 1 squared plus 1 squared equals c squared. So 1 plus 1 is 2. So 2 equals c squared. So c is going to equal square root of 2. So this is square root of 2 and this is square root of 2. So my perimeter, so this was my area before, my perimeter is going to be 2 of the square root of 85 plus 2 of the square root of 2 units. And that will give me the perimeter of this figure. On the last one here, number 17, it says, are the lines that pass through these points and these points parallel, perpendicular, coincidental, or none? For them to be parallel, what we need them to do is we need them to have the same slope. So that's the first thing we're going to do is find the slope. So we're going to find the slope of this one here first. So putting my subtraction signs and bars in. So y2, which is 2, minus y1, which is -1, over x2, which is 4, minus x1, which is 3. And let's clean this up. 2 minus -1 would be 2 plus 1, which is 3, over 4 minus 3 is 1. So that's going to be a slope of 3. Let's do the slope of the second line here. So same thing. So y2, 4, minus y1, 1, over y2, -3, minus y1, which is 1. And that's going to be 3 over 4, so -3/4. So if we look very carefully at this, one of these has a slope of 3, and one of these has a slope of -3/4. For them to be parallel, these would have to be the same, so that's out. For them to be perpendicular, it need to be opposite, which it is, and reciprocal, which it's not. And for them to be coincidental, these would have to be the same slope and essentially the same line, so that's out. So the answer to this question would be none.